is Tommy, and today we're talking about combining k-values. Find the k-value for the equation 3a plus 2b yields c plus d, and we're given various different equations to figure it out. So what we have to do is something akin to Hess's law, where we have to manipulate these and find out the k-values that we need to combine in order to find our overall k-value. So, first of all, we need 3a, and looking at this, we already kind of have 3a. So then we go to b, and then we realize, ooh, we need 2 of those, and the first reaction is the only source of it. So we need to multiply the whole thing by 2 in order to get 2b. So unlike what you might think, where you might multiply the k-value by 2, we're actually going to square it. And it's kind of like how when you use stoichiometry and the concentration in these reaction quotient or equilibrium constant equations, instead of multiplying your concentration by the stoichiometry, you raise it to that power. And it's the same thing when you're working with these equations. So I'll go ahead and write to the side, 4a plus b, or 2b, yields 2c plus 2e. So now that we have 4a, we need to get rid of an a so that we can go back to 3, like we have in the overall. So I'm going to multiply this by -1 to signify reversing it, so we can put an a in the product to cancel out one of these a's in the reactants over here. And just like what we did up here, we're going to raise k2 to the negative first power, or 1 over k2. So we're taking the inverse of that to signify us reversing the reaction. So now we're going to have e plus 2c yields a plus 2d. So right now we can go ahead and start canceling. So we have 2c here and here, so they're going to cancel. We have 2e here and an e here, and we have 1a here, and we can make this 3a. So now all we're left with is 3a plus 2b yields 2d. So now that we have that, 2d plus e. So now that we have that, let's look at our third equation. And if you notice, it's already, we don't really have to do any manipulating, it's already kind of perfect. So we do e plus d, the e's cancel, and the d cancels here, and we get 3a plus 2b yields c from here plus d, which is what we're looking for. So now, instead of adding them all together like you would with enthalpies in Hess's law, what we're going to do is actually multiply all these k values to get our overall reaction. And when you do that, you will get k1 squared times k3 all over k2 as our k overall.